Now, next topic, that is the speed of efflux or Torricelli's law. Efflux means the flow of a fluid which one is coming out from the container. Okay. Now see here, suppose as shown in the figure, we take one closed container in which there is a hole in this particular container from the bottom at height y1. Okay. Now suppose in this particular container we fill the liquid up to height y2. Now here suppose the cross section of this hole, that is A1, and the cross section of the container, that is A2. Now if the liquid is coming out from this hole, at that time suppose its velocity is v1, then inside the container the level of liquid will fall, and suppose that level move in downward direction with velocity v2. Now consider 2 points here, one at the opening of the hole and another point that is at the surface of the liquid filled in the container, and apply Bernoulli's equation at these 2 points 1 and 2. So we can write at point 1 P1 plus half rho V1 square plus rho GY1, that is equal to at point 2 P2 plus half rho V2 square plus rho GY2. Okay. Now here hole is open to air. It implies that pressure P1, that is atmospheric pressure. And suppose at point 2 at the surface of the level of liquid, the pressure P2, that is we say pressure P. Okay. Now say, as per equation of continuity, we can write A1 V1 equal to A2 V2. So V2, that is A1 upon A2 into V1. But this A2, that is too much large compared to A1. So if A2 is too much large compared to A1, then this ratio, that is very small. So in that case, you can consider V2, that is nearly equal to 0. આપણે velocity of the fluid coming out from this one એ find out કરવાની છે, એટલે V1 find out કરવાની છે, એટલે આપણે V2 ને discard કર્યો. So we can write the equation P1 plus half rho V1 square plus rho GY1 equal to P2 plus rho GY2. Now we want to find V1. So half rho V1 square, take these two terms on right hand side. So P2 minus P1 plus rho GY2 minus rho GY1. So half rho V1 square, that is P2 minus P1 plus take rho G common here. So Y2 minus Y1. So V1 square equal to 2 into P2 minus P1 upon rho. This one is taken on right hand side. Plus 2G by rho, rho cancelled. So 2G into Y2 minus Y1. Take square root on both the side. So V1, that is 2G Y2 minus Y1. But this Y2 minus Y1, that is called H. H, that is the depth of the hole from the surface of the liquid. And from figure you can write H, Y2 minus Y1, that is H. So here we can write 2GH plus 2 by rho P2 minus P1. So V1 equal to under root 2GH plus 2 by rho P2, that is P, and P1, that is PA. So this is the equation for the speed of efflux. Clear to all of you? Now take one special case here. Suppose this container is open from the top. If container is open from the top, then this pressure P, that will be equal to atmospheric pressure. So in this particular equation, if you write P that is equal to PA, then PA minus PA, that is 0. So in that particular case, V1 that is under root 2GH. And this is called Torricelli's law. So here we can say this thing: for the open container, the speed of the efflux from the hole, that is equal to the speed of the free falling body from height h. Clear?